is a diagram of a cube, and it is saying that AH, which is this line here, let's try and make it, that's not a falling line, equals 11.3 correct to the nearest millimetre. So that means that we're doing a sort of bounds question. So the higher one would be that, lower one would be that. So it's between 11.25 and 11.35 is the bounds. Let's just do that. X. Now, calculate the lower bound for the length of an edge of the cube. Okay, well this is all very good because this bit here is an edge, but this bit here is the hypotenuse of these two edges. So if we call that y, we call that x, we call that 11.25, then we know that x squared plus y squared equals 11.25 squared. But that's not all that helpful. So what we can do is we can find out what y is. So y squared equals x, so it's x squared plus x squared. So now we know that 11.25 squared equals x squared, and y squared is x squared plus x squared plus x squared equals 11.25 squared. So we know that 3x squared equals, let's find out what 11.25 squared is. I don't know, something. So equals 126.5625 divided by 3 equals 42, so x squared equals 42.1875. So x is going to be somewhere between 6 and 7, so square root that. So let's try that again. Square root 42.1875 equals 6.49, so x equals 6.49 or 6.5 centimetres. Right, okay, here we have, I think they're two hexagons, one within the other. So A, B, C, D, E, F is a regular hexagon with sides of x. So this is all that. And this hexagon is enlarged from centre F by a scale factor of P to give us this, so that's substantially better. Show that the area of the shaded region in the diagram is given by, gosh. Okay, so let's start off by working out what the area of the smaller hexagon is. And then, so I'm thinking that is an equilateral triangle, so that is going to be, so it's going to be, whatever it's going to be 6 times, and we've got to do x times, and that's going to be, let me just redraw that triangle. So this is, let's call that 1, that's half. I think this is going to be √3/2, but I could be wrong, and that one, but mainly because of doing similar things. So that would be 1 squared minus half squared equals y squared, so that's 1 minus a quarter equals 3/4, but that's √3/4, so it's √3/2. So basically the area of this is going to be x times √3/2x, which equals 6 times root 3 over 2x, which equals 3 root 3x. So that's what that bit equals. I might get rid of the stuff in the middle because now I've got to think about proportion. I mean, do I? I suppose I do. Right, now, let's just look at this. So this bit here, I'm going to have to take that bit away. So we're going to take that one away from whatever. So this bit here equals x, and then it's, so it's px. Okay, so we do all of that again with px is going to give us what f, k, j, I, h, g is. So px, there we go. So it's going to be 6 times px times, and then that would be the same thing, so root 3 over 2 px, which equals root 3 over 2 p squared x squared, I think, times 6, is root 3 over root 3 root 3 p squared x squared. Don't do what I just did. It's like self. So that means that 3 root 3, I don't get 3 root 3 over 2, sort of minus, so 3, right, through p squared x squared minus 3 root 3 x squared. Hold on, that does have to be x squared. X squared. Hang on. Yeah, but that still times that out. And that still times that out. So if we do... Aha! It's the half. Do you know what I haven't done? What I haven't done is the thing that I always forget to do, which is that this is a triangle, and I forgot to times it by half. So it's actually 3, so that means we do leave that as 2. And that is actually that, so we do leave that as 2. So we put that in there and put that in there. And now this means that I've got 3 root 3, 2, p squared minus 1 x squared. So it does sort of work. There we go.